Hi, my name is Sri Harish Mandigam, Srivasavi Engineering College, Triple A Department. Today I am going to explain about second year, fourth semester, Triple A subject, that is Induction and Synchronous Machines. The course code is B23WT07. In this subject, have a induction machines and synchronous machines. These are divided into 5 units. In these 5 units, at the end of this subject, we'll learn about construction and operation of three-phase induction motor and analyze the performance of three-phase induction motor. In the third outcome is working and construction of single-phase induction motors. The fourth one is analyze working, construction and performance of synchronous generators. And fifth one is working and construction of starting methods of synchronous motors. Certainly, first unit describes some constructional and working principle of three-phase induction motors, how it will be work based on three-phase supply, how it will be induced in the EMF in the rotors and frequencies at standstill condition and running conditions. You can see this unit how mechanical power developed in the induction motor mathematically, and we need to represent equivalent circuit and phasor diagram. Let us see what is three-phase induction motor. It's basically any machine, it is a main electrical machine, any electrical machine which will convert some form of energy into another form of energy. That too is the electrical machine is divided into, you can see it as electrical machine generators and motors. Generator which will convert mechanical energy into electrical energy. Motor which will convert electrical energy into mechanical energy. It's a very wonderful nature in three-phase induction motor. We are using AC motor, that too three-phase AC motor. By using three-phase AC supply, we can convert electrical energy into mechanical energy. In this machine, you can see what is the construction and working operation of three-phase induction motor. Any machine consists of a stator and rotor in the generator or whatever it is motor. In this three-phase induction motor, it consists of a stator and rotor. It is mounted on some basement. You are assuming stator is mounted in the base, and this rotor is placed in the inside of the stator system. In between there is some air gap. Air gap is the minimum air gap. Basically, we are giving three-phase supply is given to the stator, then some mechanical power will be developed in the rotor. How it is going on based on construction and working principle, we will discuss in the next session. But basically, in three-phase induction motor is very popular motor in our electrical systems. Is a very important load. That's why we need to discuss about some special features of three-phase induction motor. Is a very important feature is self-starting motor. Unlike some DC motors, unlike single-phase induction motor, like synchronous motor, this motor is the self-starting motor. This motor is the self-starting motor. Sorry. Self-starting motor. It is automatically, if you will give the three-phase supply to the stator, it is automatically power developed in the rotor. That's why this machine is self-starting machine and simple and robust. It designs brushes. There is no brushes. There is no commutators. There is no unnecessary other complex constructional equipment. Is a simple motor and robust motor. That's why this is a very low maintenance machine motor and compared to other motors. It's have a higher efficiency, approximately 85% to 95% of energy to work. And one more thing is almost constant speed. It maintains steady speed from no load to full load operations. Very little bit changes compared to other motors, but these changes very minor. So this machine is self-starting machine, simple and construction is a popular best machine for the different loads. Previously, this machine have some drawback, that is speed control is not easy, but nowadays we are using power electronic controllers. By using power electronic controllers, this three-phase induction motor also can control easily. Okay, let's see the what is the construction. It consists of a some three-phase winding, that is steel frame. Here see this steel frame. In this steel frame you are using some set of windings. We are giving three-phase supply to the three-phase supply RYB, three-phase supply to the stator. This winding also three-phase winding, three windings may be connected in star connected or delta connector. These windings we need to place each and every force physically 120 electrical degrees, and also we need to maintain mechanically 360 degrees, 120 degrees apart. When connected, three-phase supply is connected to this winding, AC supply is given, alternating magnitude will be developed. Due to these three windings, there is a RMF, rotating magnetic field will be developed in the stator. How it will be producing, we'll discuss in the working principle. But at a constant speed, we'll call it as this constant speed is, we'll call it as a synchronous speed. This is mathematically indicated by 120F by P, where P means number of poles of the stator, where F means the supply frequency, where F means supply frequency. But in this, one more thing is coming to the rotor. Here there is a two types of rotor, squirrel cage rotor and wound rotor. It is also called it as a slip ring rotor. Same for the two machines, for the two rotors, stator is remains same. Only rotor only changes. In this rotor, it is a squirrel cage, means it consists of a copper and aluminum bars and short circuit by end rings. Okay, we'll show the diagram. Wound rotor is nothing but it is also having a three-phase winding, is connected to slip rings, which is allowing some external resistance for starting. In the starting some machines, so we need to produce high starting torque for some applications. For that applications, we are using wound rotor. By using external resistance, we can increase the torque and all. That's why we are divided into two type of rotors. One is squirrel cage rotor, another one is wound rotor. Squirrel cage rotor is a fixed resistance. It is enclosed or short circuited with by end rings. But here wound rotor is three-phase winding, is rotor winding is connected to some external resistance starter through slip rings. Here rotor saws are already skewed for any machine, but both machines these are skewed to reduce noise and to provide smoother torque. These rotor and stator and rotor will be placed through some air gap system, stator and rotor. This air gap is very small, around 0.5 mm to 4 mm only, where the magnetic field interacts. Okay, next, any interacts. These are the squirrel cage rotor, these are the slip ring wound rotor, slip ring or wound rotor. But this rotor, this already bars, these all rotor conductors, all rotor windings in this squirrel cage motor, all rotor windings are enclosed with this end ring. We'll call it as a end ring, enclosed with. There is no possible to change the rotor conductor resistance. But in case of slip ring induction motor, this is the rotor windings. These each and every winding is connected through slip rings through slip rings, but there is some external star connected rheostat will be available. This is also short circuited. But in both cases, rotor winding is short circuited. But in case of squirrel cage rotor, there is no chance to change the rotor resistance. In this, we are creating some facility to change the rotor resistance under running. There is by changing this rotor resistance under running, there is some changes. Rotor resistance varies. Due to this, some torque and speed variations will be takes place in the machine. Based on this, we will classify into two types of induction motors. One is squirrel cage type of induction motor. Another one is slip ring type of induction motor. The only one changing is rotor part only. Two types. Based on rotor two type parts, we will call it as a two types of squirrel cage induction motor or three-phase induction motors. This is a one more description, construction of squirrel cage and slip ring induction motor in this simple and robust construction. But this rotor is short circuited by using end rings, but there is no external resistance connection, external electrical connection is electrical connection is required. But in case of slip ring induction motor, there is a external resistance is via slip rings and brushes already shown in the figure, which allows the variable resistance control due to with the help of some controlling and starting current and torque. So finally, we will see how it will be constructed. Next, we will see the working principle operation of the three-phase induction motor. Okay, for in this machine, stator consists of a three-phase winding, stator consists of a three-phase winding, stator consists of a three-phase winding, stator consists of some three-phase winding, rotor also consists of some winding, but rotor winding is short circuited. Okay, we need to give the three-phase AC as a electrical input. Okay, in this rotor we will get the mechanical power development, mechanical energy, that is mechanical power development. Okay, based on this three-phase induction motor will convert into three-phase AC electrical to mechanical output. How it is going on pin to pin from three-phase AC to mechanical output. Any motor will convert electrical to mechanical, but in this three-phase induction motor we are giving three-phase input because so many advantages based on three-phase. We will cover the entire winding with a 360 degrees by using three-phase supply. In this three-phase supply, we have one more advantage. We are minimizing, due to three-phase supply, we are minimizing third harmonic. That's why we will tell us this machine is robust and simple construction, that too noiseless motor. So based on this construction also, we can represent electrical winding connections. Three-phase supply, this is the stator winding, this is the open, if it is open circuited rotor. Open circuit, you are closing now, that's where rotor winding short circuited means this construction winding is stator and rotor will be like this. But in between there is some air gap. In between there is some air gap. In between there is some air gap. In this air gap, magnetic field interact with the rotor bars. Your magnetic field with flux, stator flux will cuts with the rotor conductors. Based on Faraday's laws, there is some EMF is induced in the rotor circuit. That will be shown in the working principle of three-phase induction motor. Clearly, we will animate the videos also. We will show the animated videos. So don't worry. We'll see the production of, first we will discuss about how rotating magnetic field will be developed. When three-phase supply is given to the stator, first we will discuss generator. In the first stator, RMF, rotating magnetic field, be developed. How it will be developed? In this, I will tell about the graphical representation as well as physical representation. We can assume like this is the stator. In this stator, we are giving some like this. In the R phase, we are giving R dash. This is the entering terminal. This is opposite terminal. Here, based on this winding, here there is some north pole creates based on magnetic field. North pole creates, here south pole creates. Likewise, we are giving 120 degrees electrical as well as mechanically. Already discussed earlier, mechanically. So second winding is, this is the R winding. Second winding is we are giving like this physically. Okay, this is like a Y dash. Here one north pole is produced. Here one south pole is produced. Next, third winding, already this is phase 1, phase 2 already represented. Coming to the phase 3, one more after 120 degrees, we are giving like this. This is B winding. Phase 1 means R, means we are assuming R. Phase 2 means we are assuming Y. Phase 3 means we are assuming B dash, like this. Here one north pole is created, here one south pole is created. This is looks like a 3 windings placed electrically as well as mechanically. Okay, for these two, what is the angle between these two? First we will assume this from R phase 2. This is also 120 degrees. Here this is also 120 degrees. From this two, this is also 120 degrees. This is also 120 degrees. Okay, so based on this, we will see the what happening in the stator means. What happening in the stator means, this is the stator. Here. Again, we are trying. First, this is 0 degrees. Next, this is 120 degrees lagging. This is 240 degrees from the 0. But each and every one is difference is 120 degrees each. 120 degrees each. 120 degrees each. Okay, based on this, we will assume the 3 pair of magnetic poles. 3 pair of magnetic poles. Here again you are drawing stator. Stator. We are assuming first phase, blue phase. First phase is blue phase. This is just like a R dash. R dash. Based on this, here one north pole is created. Here one south pole is created. Okay, again, next, second phase is we are assuming Y phase, 120 degrees, Y phase, Y dash. Y. Here north pole is created, here south pole. How it is creating, we'll explain. Only you are assuming positives. Only you are assuming positives. Next, third phase is RYB. Here B dash. Here north pole is created, here south pole is created. Creating like this. But you are always we are explaining, we are telling this is starts from 0, phase 1, our phase start from 0, this is 0 degrees. This starts from after 120 degrees, we are representing here, we are start from after 240 degrees, we are starting like this. For every positive phase, one pair of poles we are assumed like this, for R phase, Y phase, B phase. But after 180 degrees, for any alternating quantity, that may change from positive to negative after 180. After 180 degrees, for any alternating positive to negative, negative to positive, that will be change. At that time, for each and every phase, north is act as a south, south is act as a north. Okay, this means we will call it as for each and every winding there is a magnetic pole alternating. There is a magnetic poles alternating. In this way, you can see this stator, every stator, three-phase stator, every three-phase stator, north pole and south pole, north pole and south pole, north pole and south pole. We are representing. Each and every pole will be alternates for every half cycle. For every half cycle, this will be every half cycle. It will be changed north to south, south to north. In this way, rotating magnetic field will develop in this stator. In this way, rotating magnetic. Okay, if you see like this, every pole is alternating means it's like a on and off position of the lighting. Okay, if you place the lights, one is red light, one is blue light, it's always blinking on off means it looks like a rotation. Okay, that is the beauty of three-phase supply. By using three-phase supply, we can produce alternating magnet, not only alternating magnetic field, we can produce the rotating magnetic field. This will be rotates at a speed of ns is equal to 120 f by p. Here, by using three-phase AC supply, ultimately we are telling about by using three-phase AC supply, we can produce the rotating magnetic field will be like this. These are the three conductors we are assumed in this animation. These are the three windings, three single turns. By using like this, if you are giving supply, this magnetic field will be changes like this. This change is like a rotation. So this three-phase supply magnetic field, production field is called it as a rotating magnetic field. Okay, whenever a three-phase supply is given to the starter, rotating magnetic field will be set up in the stator. Rotating magnetic field will be set up in the stator. Whenever a three-phase supply is given to stator already three-phase winding. Okay, this will produce rotating magnetic field. Already previously, this rotating magnetic field is nothing but a changing magnetic field. This changing magnetic field will cut the rotor conductors. This changing magnetic field will be cuts the rotor conductors. What will happen according to this changing magnetic field? Stator RMF will cut the stationary rotor conductors. What will happen according to Faraday's laws? The EMF is induced in the rotor conductors. According to Faraday's laws of electromagnetic induction, okay, wherever a changing magnetic field will go and cuts the stationary conductors, there is a EMF is induced in the rotor. But there is already construction point of view, we discussed about there is no rotor, there is no in the rotor. Whenever a three-phase supply is given to the stator, three-phase supply, this RYB rotating magnetic field is three-phase supply. This magnetic field go and cuts the rotor conductors. Whenever a rotor conductors cuts the changing magnetic field, already there is a EMF is induced in the rotor bars, induced in the rotor bars. But already rotor is short circuited. Already rotor is short circuited. Due to this short circuit, this rotor is act as a full winding. This rotor is act as a short circuited means, okay, this induced EMF is circulates. This induced EMF is circulates a current. This is rotor current. In the rotor, there is already internally short circuited rotor. So, due to this induced EMF, there is a circulating current flows through the rotor conductors. So, already next already these same conductors, rotor conductors, is act as a current carrying conductors. Current carrying conductors. According to motor principle third law, whenever a current carrying conductor cuts again magnetic field, motor principle, whenever a current carrying conductor cuts the same magnetic field. Again, due to rotating magnetic field only, EMF is induced and circular current is flows through the same conductors. Then same conductors is act as a, whenever a current carrying conductor cuts the same RMF, there is a conductors experiences a force. There is no chance to go out the current. So here same conductors is act as a current carrying conductors. Whenever a current carrying conductor cuts the same RMF, conductor experiences a force. This is due to this action, this rotor try to rotates. That is based on this principle. Okay, once rotor started, there is a additional EMF is induced in the rotor. Like this, there is some electrical three-phase AC creates RMF in the rotor, in the stator. Due to this RMF, there is a mechanical torque force. Distinct force is nothing but a torque developed in the rotor. This is a simple working principle. Without this RMF, we can't produce this mechanical force in the rotor. Due to already this stator rotating magnetic field is moving, that means changing and cutting into the rotor conductors. There is EMF is induced in the rotor conductors. Due to this induced EMF, some circulating current flows through the rotor bars. Same rotor bars is act as a current carrying conductors. So that current carrying conductor placed in the same magnetic field, this rotor experiences a force. So due to this force, the rotation takes place in the rotor. Then you will convert into three-phase AC to electrical to mechanical energy. So these are the working principle main points. Three-phase AC supply is applied to the stator winding. Rotating magnetic field is produced in the stator. So this magnetic field will cut the rotor conductors. According to Faraday's laws of electromagnetic induction, an EMF is induced in the rotor. The induced current interact with the stator magnetic field, produce torque. Therefore, rotor starts rotating. This is the working operation. Okay. This is one more beauty is this is single excited. Only three-phase supply is given to the stator. There is no need to give the any other supplies. So this machine is also called it as a self-starting machine and single excited machine. Single excited motor. Three-phase AC to rotation directly. Same supply, three-phase supply, same supply is used to produce magnetic field, same supply is used to induce the EMF. That's why this motor is a very, very popular motor, simple and rugged motor, and self-starting motor also. So many applications are there. The pump you can use it as a submersible pumps, main pumps, water pumps, whatever pumps this three-phase induction motors is using, and fans also be some fans are three-phase induction motors are using for compressors, conveyors, industrial drives. So many applications are there. This some small animated video. Okay, whenever three-phase supply is given, there is a three poles are developed due to three-phase AC supply. These three poles are rotating. Based on this rotation, magnetic field only rotating, but here rotor bars are physically rotating. Here three-phase supply magnetic field are rotating only three-phase supply physically not rotating, but magnetically rotating. That is Ns is equal to synchronous speed 120 F by P. Okay, due to this RMF is physical, not a physical speed. That is only rotating magnetic field is rotating. Then the rotor starts. That is represented by NR. This is always less than Ns, because here this is RMF speed but is not a physical speed. This is physical speed. This is always less than the synchronous speed, but nearer to synchronous speed try to rotate. Due to some losses, due to some internal skewness, there is no equal speed to the synchronous speed. So this is analyzed by using some mathematical relations, synchronous speed and slip in induction motor. What is the slip? We'll see the next slide. But synchronous speed is nothing but Ns is equal to 120 F by P, where F means some standard frequency. In our India, we are maintaining 50 Hz. P means the three-phase poles. Three-phase winding is given to the stator. No, there is a creating three pair of poles. The pair of poles, three pair of poles means total poles are 6. Based on this, we can decide the synchronous speed of the induction motor also almost RMF. That is 120 into 50 divided by number of poles are 6. Three-phase is given to the stator. Three-phase is three-phase creating three pair of poles. That is 3 into 3. 3 into 2 is nothing but 6 poles. For this, we will get around 1000 RPM. Ns. Okay, this will create the RMF only. It's not a physical speed. Coming to the physical speed, we will assume as a NR. We are assuming as a NR. That is difference between Ns, that slip, and NR, rotor speed. That is synchronous speed and that is the speed of the rotor. The rotor is always less than the synchronous speed, but difference between speed of Ns and Nr will call it as a slip. That is based on, this slip is based on air gap between stator and rotor. Okay, we are giving three-phase supply to the stator. This is try to rotates at a Ns. In this stator, you are inserting rotor. This rotor is creating, in this rotor, creating mechanical power. This is physically rotating, that is representing NR. The difference between the synchronous speed of the RMF and physical speed of the rotor, will call it as a slip. Okay, in this you can draw the diagram, characteristics of the speed and torque. These are some variable changes happen in the machine. Okay, based on this slip only we can analyze the difference between stator and rotor changes. But in this induction motor, we will assume a x-axis is torque, y-axis on torque speed and slip. Okay, and torque will be changes with respect to speed and slip. Okay, here synchronous speed we are representing constant value, that is no changes. This is some drop when compared to and load is applied to the when compared to synchronous speed, there's some drop we are assuming like this. But in this way the speed increases, torque decreases, we are representing like this. Speed decreases, torque increases. This is the best example, cycling in the upward direction and downward direction. If you go for the upward direction by cycling, your speed will be low, torque will be, our effort of the torque will be higher. Under downward condition, speed will be increases, our effort, torque will be lower when compared to upward direction. Like this, here some changes will be representing speed versus torque. These two are inversely proportional with respect to slip. That is mathematically analyzed. That is ns minus slip means ns minus percentage slip means ns minus nr by ns. This is also representing 1 minus nr by ns. 1 minus nr by ns. It is a per unit slip. You are simply will see the speed between stator RMF and rotor speed, representing speed between slip factor. It is a factor between stator and rotor through air gap. If air gap is higher, slip also higher. If air gap is lower, slip also lower. The percentage of per unit value, you can call it as a percentage slip between stator speed and, that is synchronous speed, and rotor speed. But in this, generally after converting some stator to rotor, stator three-phase is supplied in the stator, some electrical power is given to the stator, your RMF is producing, that is given to the rotor through air gap. Mechanical power will be developed in the rotor. But how it will be creating EMF under standstill condition, under running condition, we need to analyze mathematically. That is also analyzed by using slip factor. Okay, before applying the load, after applying the load. Okay, starting condition, standstill condition. That means of once start motor in starting condition, there is no starting condition. Rotor rotation is zero. Rotor rotation is zero. Here, see that means this is a motor. Okay, this is the start. Okay, three-phase induction motor we are representing. This is rotor shaft. But when you are giving three-phase AC to stator, some mechanical power will be developed in the rotor. Is the entire thing is physically stable at start. In starting, there is some huge difference between stator to rotor. Stator already ns, synchronous speed is producing, but here nr is equal to, under starting is equal to 0. Okay, at start. That is simply we'll call it as a standstill condition. In this standstill condition, if you apply the slave is equal to ns minus nr by nr, means these two will be cancelled. This is ns minus NR means, this means total slip also is equal to 1. So based on this, we can call it as three-phase induction motor. Will analyze rotor EMF, rotor frequency, rotor current is, rotor power factors will be depends on the slip only. At standstill condition, always slip is equal to 1. Under running condition, it varies from 0 to 1. Here, the two always less than 1. It is always less than, not 1. Okay, the difference between NS and NR is a slip, but in terms of percentage also we are representing. That's why we will see the 1 by 1 rotor EMF at standstill is equal to ET is equal to the per phase is equal to not rotating, there is E2. We can say it as a under running, that is multiplying with the slip factor, that is E2S is equal to under running condition means S into E2. This means E2S means rotor EMF per phase during running. We are representing like this. The relation between under standstill condition, under running condition is nothing but E2S is equal to E2S into E2. Coming to the frequency, once EMF is rotating, that is also alternating. That EMF also having some alternating frequency. That rotor frequency is representing F suffix R. This is representing with S into Fs. S into Fs. That is supplied frequency S into Fs suffix. Here Fr assuming the rotor frequency. F means supplying frequency. Fs means supply frequency. S means slip. Under standstill condition, these two are equal. Under standstill condition, understanding whatever input supply is given, same supply is EMF also inducing in the rotor. Once rotor also try to rotate, there is a under running condition and dynamically induced EMF is induced in the rotor, that is multiplying with Fr is equal to S into Fs. For example, if you are assuming 50 Hz, there is S is equal to 0.04, rotor frequency will be around very less value is 2 Hz when compared to 50 Hz. Okay. Coming to the rotor current, there is any current that is equal to I is equal to E by Z value. Any rotor current. Already EMF is induced and rotor frequency E2S is assumed. Fr is rotor frequency is created. Then you find the rotor current, that is assumed as a I2 is equal to any voltage EMF divided by impedance. This EMF is rotor EMF. This impedance is nothing but R2 square, that is the magnitude of X2 resistance and inductive nature. Under running condition also, the relation will be only reactive nature will be changes because X is equal to 2 pi FL. If frequency changes only, this rotor reactance changes, resistance remains constant. Okay, this is the construction and working principle of and rotor current, rotor EMF, rotor frequencies of the three-phase induction motors. Thank you. This is a summary table on the difference between standstill and running conditions. Based on slip or standstill, it is always S is equal to 1. It's the under running condition 0 to 1. If slip varies, there is some EMF changes in the rotor, frequency changes in the rotor, current changes in the rotor, and also power factor also changes in the rotor. By using these all changes, we can mathematically, phasor diagrammatically, will discuss in the next lectures. Thank you.